A very good morning, students. Welcome back to the mathematics class. And today we shall start with the combinations. Okay. So we have studied till now. Till now we have discussed what do we mean by permutations. So a permutation is nothing but an arrangement in a definite order of objects taken some or all at a time. Okay. So what was a permutation? A permutation was an arrangement of objects. Okay, an arrangement of objects in a definite order. This is important. I have told you in the beginning also. In a definite order of objects taken some or all at a time. Okay, so and it was denoted by taking R objects out of N objects was denoted by NPR. Permutations of R objects out of N objects. Is that clear? And we have discussed what's the formula also when it is distinct objects and when it is not distinct objects. So we have finished till now the permutation. Now our next topic is combinations. So what do you mean by combinations? In the first class only I have told you combination is nothing but just mere selection. Okay, so it's just selection of things. Okay, a group or selection that can be made by taking some or all at a time. Okay, so if there are n objects and they are asking you to select or form a group of r objects. Okay, so r objects out of n objects can be selected in NCR ways. Okay, and we shall see the formula also in the later part. Okay, so now the difference between permutation and combination. The difference between permutation and combination is permutation is an arrangement, okay, in some definite order, and group and combination is nothing but just a selection. You are just picking up objects or choosing objects. You won't again arrange them. Okay, if you pick the objects and arrange them again, then what is that called? Permutation. Okay, if you just pick the items, it's nothing but just you're selecting some out of many. Okay, so that is nothing but a combination. Okay, so let's see one difference also. Okay, so these are three different color pens, right? This is a black one, this is a green, and this is a blue one. Okay, so how many objects they have given you? They have given you three objects, and they are asking us to arrange three objects, taking two at a time. Okay, so these are the three pens. Okay, it's just kept on the table. It's just kept on the table. So a teacher or anyone asks you to arrange these three objects, okay, taking two at a time, right? So these three are kept on the table now, right? So the pens on the table don't arrange among themselves, right? Automatically they can't arrange. The pen, one pen will start walking and they arrange themselves, right? So we have to pick them, right? So we have to pick them. What we are doing? We are selecting. Okay, so there are three objects. These pens don't have life. Okay, so they don't get arranged among themselves, so we have to pick them. So okay, from the table, we among the three we need to pick two, right? So I can pick black and blue, right? So this is one arrangement. Or I can pick black and green. Okay, so in this manner you can arrange the things. So permutation is selection and arrangement, right? If you have to pick those things, you have to select out of n things, you have to select r things and arrange those r things. Is that clear? So, and what do you mean by combination? Combination is nothing but just a selection, and here order is not important. Here order is not important. Is that clear? And here order is very important. Okay, we shall see some examples and try to analyze the difference between a combination and a permutation. Okay. Okay, so let's suppose they have given 5 digits. They have given 5 digits, and they are asking us to form a sorry, two-digit number or a three-digit number. Okay, so what will you do? So let's suppose we are picking 1, 2, and 3. Okay, how will you write down a three-digit number using the elements 1, 2, 3? Either it may be this one, right? Or either you may write like this, or either in this manner, right? Or either, okay, so many, you can form many, okay, etc. So what does this mean? 123. So you can call it 101 123 only when one is at the hundreds place, two is at the tens place, and three is at the units place. Okay, understand the value here. So what's the value of this number? 123. Okay, what's the value of this number? 132. Okay, it is called 132 because at the tens place it is 3, and at the units place it is 2. Or in terms of money also you can say. So this value is different, right? So since the arrangement is first one is 1, then 2, then 3, right? So this is rupees 123, you can say. This you can say rupees 231. So the value is changing, right? Because the arrangement of numbers are changing here. Okay, they are arranged in some manner. Okay, so what's the value of this? This is 321 rupees. Okay, see here in all these examples, the elements you are using is 1, 2, and 3 only. But if you arrange them in some manner, the value changes. So this is the permutation. Arrangement is this one. Exactly. So the same thing. Okay. So the question is list all the elements, list all the elements 1, comma 2, comma 3 in the set in roster form. Right? List all the elements 1, 2, 3 in the set in roster form. So how will you list them? 1, comma 2, comma 3. See, look here. With those three, we have formed a three-digit number, right? So now the other question is, list all the elements 1, 2, 3 in the set in roster form. Okay. So roster form is nothing but writing down all the elements, right? Writing down all the elements. We are taking the example of the set theory. We have studied in the first class itself. First chapter was sets only. Okay. And recently you have done the homework assignment also. And I do believe that you understand what I'm trying to tell here. Okay. So here if I list the elements as 2, comma 1, comma 3, does it matter here in set? In roster form, sir has told, okay, in roster form, listing of elements in some order is immaterial. It doesn't matter at all. This is also a set consisting of elements 1, 2, 3, and this is also a set consisting of elements 2, 1, 3, or 1, 2, 3, or 3, 1, 2. But it doesn't matter. So these all are same only here, right? These are all same here. It totally immaterial in order, the order in which you write. Is that clear, students? So here if you see, all are same, one and the same, but here it's not same. Okay, so these are some specific different values. So it is called, okay, all the elements are 1, 2, 3 only, but since they have been arranged in some manner, the value is different. And here if you see, all the elements are 1, 2, 3 only, but listing all those elements in the set is immaterial. The order does not place an important here. Okay, order is not important here. But in this case of example, order is important. Is that clear? So that's what. So permutation means order is important, and combination means order is not important. Okay, you can see by there are few more examples. Okay, first understand the difference between permutation and combination. That's it. Because usually students find it difficult where to use NPR and where to use NCR. Okay, where to use permutations and where to apply combinations. Okay, there is one more example also we can see. Okay, so these are four different students. Okay, so these are four different students, and we have to select or make a team, okay, for the lawn tennis use. Okay, so we have to make a team. So it's a doubles team means we have to send two players, right? We have to send two players. Okay, we have to send two player name to the for the competition, right? So I say, okay, we have selected A and B as a team to represent our college in the lawn tennis competition or badminton, you can say. Okay, so I am sending a group of A and B student, right? So first we will hand it over to the principal, right? Sir, A and B players are very good, so let us send them to the competition. Is that clear? So, but sir rejects the team, says, okay, find some other two boys or other two girls to represent our college. Okay, then again we will go to the sir with these names. BA, right? So now look here. Am I taking the same team or am I taking the different team here? Right? So A is also, this is a team consisting of A student and B student. And this is also a team consisting of A student and B student. So here selection of team, the order doesn't matter, right? Here selection of team order doesn't matter, right? So this is a team comprising of A student and B student, and this is also the same thing only, right? So here AB in combination AB is similar to BA itself. It doesn't matter here, order doesn't matter. Is that clear? Okay, you're just making a same team only, right? So it doesn't look like two different teams, right? So here in the combination order is not important. Okay, so now let's suppose all these four students have gone for the running competition. Okay, so for running competition, right? So they are running. Okay, so they are running, so there has to be three students who have come first, second and third, right? Is that clear? So there are three positions. Okay, so first rank, second, third. Okay, out of the four students, all the four students are running, or you can add few more also. There are five students running. Is that clear? So when they are running, so how will you decide who has come first, who has reached the cross line first? First one, right? So now look here. Here A can also be the first winner. B can also be the first winner. C can also be the first winner. D can also be the first winner, right? If A is the first winner, B may be second, or C may be third rank, right? Or D may be second rank and A may be third rank, right? So here some order is there. Okay, so now they have won the competition. Now they have won the competition and came back to the college. Okay, we need to felicitate them, right? So if we put the photos in the newspaper, the first photo will be of the first ranked student, right? You can't put the 100th ranked student at the first. So an arrangement in some definite order. Okay, so 10 students have scored the top 10 ranks. So how will you put them into a newspaper? In some definite order, right? You won't put the 10th ranked student photo at the first place, right? So there is an arrangement. After first, second ranked student comes. After second ranked student, third ranked student comes. Is that clear? So what I'm trying to tell, an arrangement in definite order is a permutation, whereas just a selection or just a group is nothing but a mere selection, and that is combination. Okay, just understand this one, students, the difference. It will be easier for you to solve. And we shall see two more examples and start with the formula. Okay, so now the next one, just imagine there are 10 friends. Just imagine there are 10 friends. Okay, so the 10 friends meet. Okay, long lockdown has been a very long period, right? So they meet after so many months. Okay, so when they meet, they handshake each other, right? So let me suppose there are two students, right? So A shaking hand with B and B shaking hand with A. Both are one and the same, right? I am shaking hand with B person or B shaking hand with A person. So does the order matter here or does it accounts for two handshakes? Okay, so we need two persons for a handshake, right? We need two persons for a handshake. So either A handshake with B or B handshake with A. Both are same, right? Both are one and the same. Here order doesn't matter, right? So this is also one of the case of a combination. Okay, or very easily you can say in, okay, how will you say this is a triangle ABC, or you can say this is a triangle ACB. Does the order matter here? It doesn't matter. Either you read it ABC or ACB or CBA. So all these indicates a triangle consisting of 3 points. That's it. Okay, three vertices. Is that clear? Here order is not playing any role here. Okay, so that's the difference. So permutation means keep in mind now, permutation means and selection and arrangement in some order. So order is important here. Okay, but in combinations, order is order is not important. Okay, it doesn't matter. So now we shall start with the next concept. Okay, so we shall see a formula to find the number of combinations of n distinct objects. Combinations means keep in mind selection. N distinct objects out of R objects. Okay, taking some more all at a time is denoted by NCR. So what's the formula for distinct objects? When they ask us to arrange the things, NPR is equal to n factorial by n minus r factorial. Now we will see what's the formula of NCR. Okay, students. Okay, so now let us consider an example of let us consider an example of selecting and arranging things, right? And what are those given? A comma B comma C. There are three objects given. So what is n here? N is 3, right? So now let us see. So based on this we shall see permutation as well as combination. Okay, okay, students. Okay, so in the first time, they are asking us to arrange one object out of three objects, right? So how many objects are given, students, here? N equal to 3. And what are those? A, B, C. Okay, so what are those? A, B, C. So NPR, 3P1. Okay, so what is N here? N is equal to 1. And in the first case, they are asking, N equal to 3. Three objects, A comma B comma C. Three objects they are given and they are asking us to take one at a time. So what will be the answer? 3p1 is equal to 3 factorial by 3 minus 1 factorial, which is equal to 3 into 2 factorial by 2 factorial get cancels and I get it as 3. So when you arrange one out of three objects, how many you are getting? 3. And we have derived it in special cases also. NP1 is equal to 3. And let me list them. What will be those? Either A or B or C. Is that clear? Now let's come to the combination and see. So in combination, what are they saying? Select one object out of three objects. Okay, you don't know what is the formula still, but let's understand by listing the things or the objects here. Okay, so out of out of three, you have to take one at a time, right? So among A, B, C, either A will be there, B will be there, or C will be there. By formula also, okay, you can either select A, or either you can select B, or either you can select C, right? So how many ways you can select? Okay, in three ways. Is that clear? And let's see, suppose if you take two at a time. If you take two at a time, so what will be the permutation? 3p2. So taking two out of three. So what's the answer here? 6. And let me list all those things and see. So what you are doing, taking two at a time, right? So A, B, right? Or you may take AC, or you may take BC, right? Or you may take BA or CA, CB, right? So here arrangements, how many arrangements you can make when you are taking two at a time? 6 arrangements. 3p2 is equal to 6. Now in case of selection, students, in case of selection, R is equal to 2, 3c2. So let's see what will be the answer, right? So see here, okay. So this has been done after arranging things, right? So here AB is same as BA. In case of permutation, it doesn't matter the order in which it is written. The order is totally unimportant, right? It's not important. So AB you can take. Either you can take CA, right? So either you can take BC, right? So either, see, look here, these and these all are same. Okay, it doesn't matter at all. Okay, so what is the value of 3c2 here? 3c2 is nothing but you are getting 3 only, because AB is same as BA. So in combination you will pick either one, right? And AC is same as CA, right? So and BC is same as CB. Okay, so in the combination you are getting 3. Okay, so now the formula, by formula you are sure that 3p1 is equal to 3, right? And 3p2 is equal to 6. So I have told you in permutation what we do, we select the things and arrange those things among themselves. Okay, so now look here. So can I say 3p2? Okay, you are arranging two things out of three objects, right? You are arranging two things out of three objects. So first you need to pick those things or select those things. So what is that? You are selecting two things. You are selecting two things out of three, right? You are selecting two things out of three objects, right? But we are talking about permutation. So the arrangement is not done yet. You have just selected two out of three, and the arrangements is, okay, so how many objects you have picked? Two objects, right? And you're, how can you arrange those two items? Two items can be arranged among two places, right? 2p2, 2 factorial. Okay, so now let me see whether this is satisfied or not. So what's the value of 3p2 we got here? 6. Okay, what's the value of 3c2 we got here? 3, right? Into 2 factorial. 6 into 3 into, okay, what is 2 factorial? 2 into 1. Now is it clear? So have you established some relation between permutation and combination? Okay, so what is permutation? Okay, selecting things, and after selection you are arranging those things. Okay, just a selection is a combination, but selecting and arranging those things is nothing but a permutation. Is that clear, student? So similarly you can write down a general way also. Okay, permutation of R objects out of N objects is selecting R objects out of N objects and arranging those picked objects. So R objects have been picked, so it's nothing but it can be arranged in R factorial ways. So this is our first formula, and the relation between permutation and combination, students. Okay, so NPR is equal to NCR into R factorial. So what does it indicate? Okay, Okay, so what was the formula or the relation between permutation and combination? Okay, you can say each combination, C stands for combination, P stands for permutation. Each combination in NCR, each combination in NCR will have R factorial permutations. Okay, so this is our first relation. Okay, so now let's establish a formula for the NCR, right? So what is NCR from here? You can say it's NPR by R factorial, students. Is that right? So, and what is NPR? NPR is n factorial by n minus r factorial. Okay, whole divided by, this is our NPR. Okay, this is our NPR, n factorial by n minus r factorial. So divided by r factorial. So hence upon simplification, n factorial by r factorial into n minus r factorial. So this is a formula to find combination. Okay, when n distinct objects are given and you're selecting r at a time. So is that clear, students? So what is the permutation formula? When distinct objects are given, NPR is equal to n factorial by n minus r factorial. So what's the combination formula? NCR is equal to n factorial by r factorial into n minus r factorial. Okay, so from here we shall see few more cases and then start with the problems. Problems are easy. Just understand what's the difference between permutations and combinations. Okay. So what's the difference between? It all depends upon the order. Okay. Okay. It all depends upon the order. If you read the question and you analyze it and see there is an order. If there is an order, then it is a permutation. You need to apply NPR formula. Okay, if there is no order is not important, then you need to understand it's nothing but they are talking about combinations or NCR. So the first relation we have seen is NPR is equal to NCR into R factorial. Okay, permutation, selection and arrangements. Selection and arrangements. Second one, NCR is equal to N factorial by N factorial by R factorial into N minus R factorial. Okay, so now we shall see some of the special cases. Okay, so what do you mean by if R is equal to N? If R is equal to N, what is NCN we shall see. In case of permutation, if R is equal to N, NPN was N factorial. Now we shall see what is NCN. Okay, so NCN, N factorial by, okay, N factorial by. So what is, okay, so in place of R we have N, right? So NCN equal to N factorial by N factorial, right? N minus N factorial, which is equal to N factorial by N factorial. N minus N is 0 factorial. 0 factorial is 1. N factorial by N factorial, which is equal to 1. So NPN is N factorial, but NCN is 1. Okay, but NCN is 1. Is that clear? So next one, let's see what if R is equal to 0. What if R is equal to 0? So what was the value of NP0? Arranging 0 out of n objects is 1. Okay, now let's see what is NC0. Okay, so NC0 is equal to n factorial by. So what is R here? R 0 we have taken. 0 factorial by n minus 0 factorial. Okay, n factorial by 0 factorial is 1. 1 into n minus 0. N minus 0 is n. N factorial. N factorial, n factorial get cancels. So the answer is 1 here. NC0 is also 1. Okay, so the next one you can see is what if R is equal to 1? So these you have to remember just to for the simplification. Okay, it will be very easier. What if R equal to 1? NC1, right? So NC1 is equal to, what's the formula? N factorial by R factorial into N minus R factorial. Yes, students. So whole divided by 1 factorial, right? N minus 1 whole factorial. Okay. So now can I write N as N into N minus 1 factorial upon 1 factorial is 1, N minus 1 factorial, let me keep as it is, these two get cancels, and what we are left with? N. So can I say NC1 is equal to N? Okay, so now just remember, students, NPR is equal to selection and multiplication rule. So to arrange things, first you have to pick those things, okay, or to select those things, right? Selection and arrangement of those things. So you are selecting R things, right? You are selecting R things. Now arrange those. So R objects can be arranged in R different places, right? So RPR is equal to R factorial. So NCR formula. What if R is equal to N? R is equal to 0, R is equal to 1. Okay. Now we shall see next property, and the next property, okay, NC N minus R is equal to NC. So let's see what will be NCR. These are all formulas, okay. Just remember, students, it will be easier in solving. So let's see what will be NC N minus R. Okay, so what NC N minus R. So let's apply the formula NC. N factorial by. So now look here, this is the formula you need to use here. Okay, in place of N, we have N. In place of R, we have N minus R. So R factorial will be N minus R factorial, right? So now in place, next N minus R factorial. In place of N, N. But in place of R, we have here N minus R. N minus R whole factorial. Okay, so NC N minus R is equal to N factorial by N minus R whole factorial. Okay, so N minus N, multiply minus inside, plus R whole factorial. Okay, so NC N minus R is equal to N factorial divided by N minus R factorial. N minus N get cancels. So what we are left with? R factorial. If you observe carefully, the expression on the right hand side is nothing but the formula for the permutation itself. Okay. So now can I say NC N minus R is equal to NCR. So this is also one important formula to remember. Okay. NC N minus R is equal to N. Okay, so it's nothing but, okay, selecting R objects out of N objects is same as rejecting N minus R objects. Okay. Then next one, there is one more formula. So NC N minus R is equal to NCR. Okay. NCR. So the now seventh one, NCA is equal to NCB. Okay, so NCA is equal to NCB. So when it is possible, when A is equal to B, when these are both same, either it is A equal to B or B equal to A, one and the same thing. Okay, so NCA is equal to NCB if and only if, sorry, it implies A equal to B, or by this you can say, or A is equal to N minus B. Okay, or you can say A is equal to N minus B, which implies N is equal to A plus B. So in two cases, NCA can be equal to NCB when A is equal to B or A is nothing but N minus B. Okay, why I am writing N minus B? Because using this formula, just now we have seen NC N minus R is equal to NCR, right? So now can I write NCB as NC N minus B, right? So if these two has to be equal means A has to be equal to n minus b, right? So that's why A equal to n minus b. So therefore n is equal to A plus b. Okay. So now we have seen, so these are some of the formulas. Remember it, it will be very easier for solving. Okay. So now there is one more property, but we shall solve it tomorrow. Okay, it needs some time. We shall solve it tomorrow. Let me see. We shall finish two examples and come back. Okay, so the question, example one. Okay, you can see there is a property, but we shall solve with theorem 6. We shall solve it tomorrow. It will take time. So now look at the examples here, 17. Okay, hope you have memorized by now. So the formulas. Okay, so we'll use one by one wherever is required in the problem. Okay. So example 17, if NC7, NC9 is equal to NC8, okay, find NC17. Okay, the question is, if NC9 is equal to NC8, find what is NC17. So just now we have seen, if NCA is equal to NCB, there are two cases. Either it has to be A and B should be equal, or n is equal to a plus b. You can solve them by the formula also. Don't worry, students. You can use n factorial by n. So what's the formula of NCR? NCR is n factorial by r factorial into n minus r factorial. Yes. So what is r here? 9. So you can use the formula and solve also. But we have a property, right? So why to use solve blend here? So it represents in this manner, NCA is equal to NCB. So it's either A equal to B or N equal to A plus B. Just now we have seen. Okay. So using this property, so now we have NC9 is equal to NC8. Okay. So which implies N is equal to A plus B. Right. So what is A here? 9. And what is 8 here? Sorry, what is B here? 8. So 9 is equal to n is equal to 17. Okay, so what we have done here, I have used a property. If NCA is equal to NCB, okay, implies A is equal to B or N is equal to A plus B. Okay, here A is 9 is not equal to 8. You can say 9 is equal to 8, right? It's not equal. So hence n is equal to A plus B, use the formula. So now we got n is equal to 17, right, students? And what they are asking us to find NC17. So just now we have solved what is n here, n value is 17. 17C 17. And in the property cases, we have seen what is NCN. NCN is 1. Okay, so 17C 17, write it directly. It's nothing but just 1. You can check by the formula also, don't worry. So NCR, what's the formula? N factorial by n minus r factorial into r factorial, or r factorial into n minus r factorial. It doesn't matter. A into b is same as b into a. Okay, so now 17c17 is equal to 17 factorial whole divided by 17 minus 17 factorial into 17 factorial. So 17 factorial, 17 minus 17, 0. 0 factorial is 1. 1 into 17 factorial, 17 factorial. These two get cancels. The answer is 1. Okay. So you can solve in this manner also, or wherever you can apply the properties or the formulas. So use them and simplify quickly. Okay. So now let's see next example. So next example is a committee of 3 persons is to be constituted. Example 18. A committee of 3 persons is to be constituted from a group of 2 men, and 3 women, full stop. In how many ways can this be done? In how many ways can this be done? Full stop. Okay. How many of these committees would consist of 1 man and 2 women. 1 man and 2 women. Okay. So the question here is a committee of 3 persons is to be constituted. Okay. You have to form a group. Committee is nothing but a group, right? So you have to form a committee of 3 persons. Is to be constituted from a group of, or from the collection of 2 men and 3 women. In how many ways can this be done? This is one part of the question. And the next part, how many of these committees would consist of 1 man and 2 women? Okay, so what they are telling in the first part of the question, okay, they have given you a data. You need to form a 3 persons committee. Okay, so that committee should have 3 persons from a group of 2 men and 3 women. Okay, so in how many ways can this be done? So so you are forming a group. Okay, you are just forming a group or forming a committee. Here order does not matter. Okay, so they are not saying the men or women should sit at even place or odd place, or vice chairman you should pick, or chairman you should pick, or you should pick what do you say, president, secretary. They have not given any positions, right? So here they are just asking, out of these persons pick 3. That's it. Okay, out of the given collection they are asking us to pick 3, make a group. Okay, so now here order does not matter. So how many total they are asking us to make a 3 persons, right? 3 persons committee. Okay, that committee should comprise of 3 persons. Okay, so how many in total are given? 2 men, and they have given a 3 women also. So total persons are how many? 5, right? So can I take it as n is equal to 5, right? So out of 5 persons, you have to make a committee of 3 persons, and this can be done in 5C3 ways. Okay, and this can be done in 5C3 ways. So what's the formula of NCR? N factorial by n minus r factorial into r factorial, which is equal to 5 factorial by 5 minus 3. 5 minus 3 factorial into 3 factorial. 5 factorial by, what is 5 minus 3? 2. 2 factorial, right? 3 factorial, which is equal to 5 into 4 into 3 factorial divided by 2 factorial. I'll write it as 2 into 1 into 3 factorial. So 3 factorial in the denominator, and numerator get cancels. Okay, so now 2 ones is 2, 2 ones are 2 twos are. So what? Okay, so you can make a 10 committees. Okay, 10 committees taking 3 at a time out of 5. Okay, is that clear? This is the first part of the condition. The second part is how many of these committees, okay, would consist of one man. Okay, that committee should have one man and two women compulsorily. See, look here, one man and two men accounts for three persons, right? That's what they are asking. But with the condition of how many of these committees would consist of one man, and that committee should have minimum one. Okay, that kind, sorry, not minimum. So that committee should have one man plus two women. Okay, so this collection should be done from two men and three women. Okay, so next part of the question, one man can be selected. So how will you pick man? You have to take it from the man group only, right? So one man can be selected from two men. Okay, you are selecting one man can be selected from two men in how many ways? 2C, one ways. There are two men and you are taking one at a time. And you need to take women also, multiplication principle, students. Remember, wherever is and is appearing, or if you come across and while understanding the question, that is a multiplication rule. If you come across or, it's a and rule. Okay, so now next, two women can be selected. So these two women has to be selected from where? From the group of three women. From three women, in how many ways you can arrange them? Oh, sorry, I'm really sorry. It's selection. Okay, we are not asking the arrange. So you are picking the women and men to form a committee. Okay, so two women can be selected from three women in 3C2 ways. Now the event is over. So hence the total number of ways in which you can pick one man out of two men, two women out of three women is 2C1 into 3C2 ways. Okay, so what is 2C1? NC1 is N. So this is 2, I'll write it directly. And what is 3C2? 3C2 is use the formula 3 minus 2 factorial into 2 factorial. Yes, students. So 2 into, so what is 3 factorial? Can I write it as 3 into 2 factorial? Whole divided by 3 minus 2 is 1 factorial into 2 factorial. So 2 factorial get cancels. 1 factorial is nothing but 1 itself, right? So this is 6 ways. So this 6 ways represent a committee comprising of one man and two women. Okay, from the given collection of two men and three women. Okay, thank you, students. We shall start the doubt session, and tomorrow we shall continue with the rest of the problems. Okay, for the example 17, just understand few things, students. So what we have done, NC n minus R is equal to NCR. We have proved this one, right? NC n minus R is equal to NCR. And then next, I was talking about the formula NCA is equal to NCB, right? So when it is equal, when they can be equal only when A is equal to B or A is equal to N minus B. So minus B shift this side. So what will be N? N is equal to A plus B. Okay. So now just understand this one. We have proved it. NC N minus R is equal to NCR. Which is, and the next formula or the next property we have seen is NCA is equal to NCB implies, so it's clearly understood. If A is equal to B, then only we can say NCA. Okay, so now look here, if A is equal to B, NCA is equal to NCA, right? Or if it's B, right? So that's why I've told you A is equal to B condition. Or there is one more condition also. A is equal to N minus B or N is equal to A plus B. So how we have taken is that, so this understanding of the second one we have taken from the first property. Okay, so now look here. Can I write NCA is equal to, okay, what is NCB using this formula? So in place of B, what it is? So in place of R, we have B, right? So now NCR, can I write it as NC N minus R? NC N minus. So what is R here? B, right? So when they can be equal, students, just now we have seen when this part is equal to this part, A equal to N minus B. That's why I have written two conditions, either A equal to B or A equal to N minus B. So N is equal to A plus B. Okay, so now we shall see the 17th example. You can either solve it by the formula or either you can solve it by the properties which we have defined here. Okay, so the question is example 17. If NC9 is equal to NC8, find NC17. Okay, so what is NCR formula? NCR formula is n factorial by r factorial into n minus r factorial. So use this formula and solve, students. Okay, so n factorial. So write the question once again. So what is the data given? NC9 is equal to NC8. Okay, so using formula n factorial by r factorial. What is r here? 9. R factorial into n minus r. So n minus 9 factorial, which is equal to n factorial by, what is r here? 8. 8 factorial n minus 8 factorial. Okay, students. So now if you see n factorial get cancels. So now can I write this as 1? It get cancels. Okay, these are similar. So 1 divided by 9 factorial. Can I write 9 factorial as 9 into 8 factorial? Okay, n minus 9 factorial, which is equal to n factorial has been cancelled now. 8 factorial as it is. Now apply the definition of factorial. So what is n factorial? N factorial is n. The next will be n minus 1, n minus 2, so on up to 3 to 1. It is getting reduced by 1. Okay. So that's why can I write n minus 8 factorial as n minus 8 into n minus 8 minus 1. So what is minus 8 minus 1? Minus 9. So minus 9 factorial. I'll stop here itself because we have a like terms on the both sides. Now those two get cancels, right, students? And 8 factorial also get cancelled. So 1 by 9 is equal to, okay, these two are getting cancelled, right? Which is equal to 1 by n minus 8. So upon taking reciprocal, 9 is equal to, or cross multiply, okay, cross multiply. So n minus 8 is equal to 9. So n is equal to minus 8, shift to the right hand side. 9 plus 8 equal to 17. So what is the value of n we have got here? N is 17. So what they are asking us to find? find NC17. So what is N here? 17C17. And just now we have seen, and 17C17 is equal to 1. 17C17 is equal to 1 because we know the property NCN is equal to 1. We have solved it. Three persons is to be constituted. Okay, we have to form a group, we have to form a committee of 3 persons from a group of 2 men and 3 women. So they are asking us to form a committee. So this committee should comprise of 3 persons. Okay, so they are asking us to form a committee of 3 persons from, so from which collection? 2 men and 3 women. Okay, they are asking us to form a 3 persons committee from a group of 2 men and 3 women. First one, in how many ways can this be done? Okay, so in how many ways can this be done? So how many total persons we have? 2 men, 3 women. So total persons we have is 5 persons. Okay, we can count them. Okay, 5 persons. So out of these 5 persons, they are asking us to form a committee. Here order does not matter here. Okay, so here committee, they are asking us to form a committee of 3 persons. So how this can be done? In 5C3 ways. Okay, so now just simplify, students. We have got the answer as what was the answer? Equal to 10. So this is the first part of the question. Next part of the question is how many of these committees would consist. Okay, so in how many of these committees means 3 persons they are talking, right? So in how many of these committees there must be 1 man and 2 women. So in this committee of 3 persons, you should have 1 man and 2 women. So you should select them. You should select them out of 1 man. You have to select 1 man and 2 women. So from the given collection, right? So 2 men. So there are 2 women. They are asking us to take one at a time. They are asking us to take men. And we have to take women also. So how many women do we have? We have 3 women. Okay. And we are selecting how many at a time? 2. Right. So it's nothing but 2C1 is 2 and this is, so what was the answer here? Okay, so what do we got? So 3, let me simplify. 3 minus 2 factorial into 2 factorial. 2 into 3 factorial. 3 minus 2 is 1, 1 factorial, 1, 2 factorial. So 3 factorial can be written as 3 into 2 factorial by 2 factorial. So it's 6. Okay, so there are 6 committees in which 1 man out of 2 women and 2 women out of 3 women is being selected.
Children, permutation is nothing but we all know this is arrangement. For example, arrange 3-digit number from 1, 2, 3, 4, 5. Okay, we're having 3-digit. Order here, 3 digits we have to arrange. And the numbers given 1, 2, 3, 4, 5. Therefore, we are having units place, tens place, hundreds place. If the repetition is, we'll take an example as repetition not allowed. You all know in the 5, 1 we can keep in this box. Out of 5, 1 kept means we left with 4, and next we left with 3. This will give total 3 into 4 into 5. Okay, ma? Or 1, 2, 3, 4, 5. It is nothing but 5p 3. Both are same. NP R. In 5 we can select 3. 5p 3 also nothing but 5 into 4 into 3. Either NPR or multiplying principle. Both are same. And if you come to combination, it is of selection depend on the condition. Suppose 12 persons making party and each other, already this we have been discussed there, shaking hands. Any 2 persons can shake the hand, that we know that there is a uniqueness there. We can't shake 3 at a time there. Okay, ma? Like this we should not shake. Shake means only hand to hand. Therefore, if you see 12 persons shaking the hands each other means we have to take the condition 2. Here selection having the condition of 2 persons making the shaking hand. And this will give 12C2. When selection is coming with the 2 persons of having n persons is called combination. Arrangement having the order condition of 3-digit, 4-digit, or make the even odd, that. By seeing the question, we come to know arrangement what and selection is what. That's it. If you read the question properly, we should have the English knowledge as well as mathematical, both we have to see for the permutation and combination.